Hey guys, hope all of us are doing fine. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. In this discussion, I'm going to look at the projectile motion. And of course, we're going to try and describe the horizontal displacement of an object that is falling over the end of a table, given in this particular case. So therefore, we are going to consider this specific object to be undergoing a horizontal displacement given as that one. And of course, this is going to be in terms of the x displacement. In this case, I mentioned that from our previous discussion, we can consider the concept of a free fall, whereby we considered only an object falling due to the, of course, influence of gravity. And we had taken this specific type of motion to be expressed along the y-axis given as that one. But in this specific case, for an object that is going to fall off the end of the table, is going to be describing some kind of an angle. And therefore, we're going to consider, in as much as it's going to be an horizontal displacement, we're going to consider these specific components in trying to describe the velocity of that particular object. So therefore, at this specific case, we are going to see that the object is going to assume both horizontal and vertical, of course, components of motion, whereby we're going to consider, of course, this specific object in terms of its initial velocity. So at this particular point, let's assume this is a point A, and falling to a point B given as that one. We're going to have its initial velocity component given in terms of this specific value for y. So this is going to be initial velocity given as that one, and this initial velocity is equivalent to the Vx naught given above. So therefore, that's going to be treated at our initial velocity. So the vertical downward acceleration, which is going to be acceleration due to gravity, is going to be a vertical component, whereby we're going to have a velocity given in terms of Vy is equivalent to displacement, or rather the change in velocity with respect to time given as that one. So therefore, we're going to have that one given as, of course, g times t, where g represents the acceleration due to gravity and t is the time taken. But if we consider the initial, of course, launching a velocity, which is going to be in terms of v y naught along the y components, this is going to be 0. So in case we consider an object so let's just reserve this one. So we consider this one to be the components which are going to be affecting that specific motion. And of course, at the particular point, we're going to see that we're going to have a resultant velocity given in this particular case of a VR. If we try to contrast this one with an object which has been launched horizontally, perhaps at an angle, then therefore we're going to have the components of this specific aspect of the vertical and horizontal displacement given in terms of this nature. So perhaps I can give it given as that one. So we're going to consider the velocity component along that one given in terms of Vy naught to show the velocity component along the y-axis being shown at that one, and it's be directed and the tangential component along that path of travel. And we shall have this aspect of the velocity component for the x given in terms of Vx and not given as that one. So we're going to consider the total distance of displacement along the x-axis, and that is going to be giving us an aspect what we are trying to describe for this specific discussion. And as I've said, the resulting velocity is going to be a tangential component to the arc of a path, while we can give the vertical displacement from the specific equations of, or the kinematic equations of motion, which were given in terms of V is equivalent to U plus gt. So this was from our first kinematic equation, whereby we're going to consider the acceleration component and the velocity from this first equation, whereby we're going to have the Vy is equivalent to Uy plus gt given as that one. Whereby I assume that we're going to understand these specific components. So for the vertical downward acceleration, we're going to have the vertical velocity component given in terms of Vy, which is equivalent to gt. So in this case, we are going to consider a case whereby we're going to have this specific initial velocity for such a kind of an object starting from 0, where we are going to have this Uy equivalent to 0 given as that one. So we're going to have this specific vertical displacement of course, from the vertical, the equation which we are given using this specific representation, from the specific kinematic equation, we're going to have this specific equation, whereby S is going to represent the displacement, and therefore we are going to have these other components just from the first equation given as that one. So for this second equation, we're going to see that initially we understood that this specific velocity upon launch as well is going to be a value of 0. So therefore, we're going to expect the displacement to be represented in terms of a half t, the square of t given as that one. And that is going to give us basically the concept of horizontal, or rather the vertical displacement, which we are going to be seeing. So we can represent this aspect of velocity, whereby we're going to see that for an object, especially which has been launched like that, we're going to have this specific aspect of velocity component, whereby we're going to have the Vx remain as a constant and equal to the initial value of this specific aspect of Vx naught. So in this case, we are going to consider two particular cases for the launch at this specific point with an initial velocity of this one, and then we're going to have the final velocity given as that one. So we're going to consider these two aspects of velocity and try to see their specific quantity, and that is going to be more elaborate, especially on our subsequent discussion. So of essence for us is to try and see how we can represent the displacement in the horizontal direction given as that one, using the two equations of motion and considering the state of launch of this specific object for the initial velocity and the final one for an object launched at a particular angle, and for a falling object which is going to be assuming of course a motion in this specific case, whereby we have decided that we're going to assume, not assume basically, we're going to see that this specific component at this specific point is going to be 0, and therefore we can describe its velocity given as that. Now for a vertical and horizontally displaced object, we're going to have the two components which are going to be added using the concept of vectors as I had mentioned. So basically we're going to have this magnitude of velocity given as a root of this specific aspect of the component of x plus component of y given as that one. And this is going to be also assisting us to try to contrast this and describe velocity for such a kind of a motion for either horizontal displacement or velocity for the two kind of descriptions given above. So kindly check our description boxes for various links of other videos. Engage us in the comment section and also ring that notification bell for an update on other discussions in the concept of motion. So that is it for now, guys. Bye, God bless you. Catch us in our next video.